Good afternoon, students. How are you?
Good afternoon, sir.
Afternoon, sir. We're doing well, but I'm not sure if it's just me, but sounds like you're breaking up.
Hello. What? How are you?
Sir, you're breaking up, sir.
Nice.
Recording in
I'm
progress.
breaking up.
Yes, sir.
Anybody
Yes,
else
sir.
having that experience? I'm breaking up. Okay. Still breaking up.
Yes, sir.
Yes,
Wow.
sir.
All right. So just let me know. So am I in the clear now?
No, sir. Still breaking up, sir.
Not really, sir.
Um, is anybody hearing the sound of my voice? Let me know who I'm coming across. Oh, all right. Guess what? Let me log out and then try coming back. Who am I coming across now? Is it any better?
Sounds a bit better, sir.
All right, good. I'm happy for that. All right. Sorry. All right, do me a favor now. Can you just touch base with the other student? Oh, careful, careful, careful. Why would you do that, sir? Why would you do that? Hmm. All right. Remind me, please, where were we the last time? What were we looking at? Oh, multivariable functions. We're looking at the, what do you call it? The stationary points.
Yes, sir.
Yes, no?
Yes, sir. Yes,
All
sir.
right, do me a favor. I would love if somebody could share for me one of those questions from a past paper. I must go into one of those past paper questions today so we can work through one of those full questions.
There was
So
a question on the worksheet that you gave us.
there was a question for homework.
Yes, sir.
All right, good. Project that question for me, please. Alwyn, if you're able, or someone. I need to see I need to be reminded of the function, so I can look at the partials. I can work the partials quickly in my headspace, and then we can discuss the other parts of the question. So if someone could just share for me the stuff, hey Tash, what you do? I should say though, congratulations to my awardees. You know, I'm truly proud of the work that you've put in and the energy that you put into your schoolwork. I'm a little disappointed that I didn't see more of it turning out, but I guess I could understand maybe the conflict with work. But congratulations nonetheless. And for those of you who were not awarded, it's an opportunity for you to work a little harder for this semester, and the other 2 remaining semesters lie for semester 3 and the other 3 semesters in year 4. So at least you can make the list. But congratulations, really, 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 truly super proud of you and the work that you put in. All right, so with that said, thank you, please, for sharing. I am
See
looking
the
at
screen?
Yes, sir. And thank you. I'm seeing the screen, but that's not the question, do you know? I think we did those. We did that the last class.
Or rank?
We did.
Or
Yeah, it's the wrong one. Yeah, we classified those the last class. Don't find it yet?
no, sir. Let me delete here, sir.
Can anybody help out Alwyn, please? All right. So if not, I can go through that a little later. Can we find out? It's always on the exam paper. Can somebody bring up an exam? Can you put your hands on an exam paper, Alwyn, please? It's always on. It's a must-have on an exam paper, and I want us to look at one because the questions that come on this topic is very wordy. It has a lot of words to it, and it asks you to do a whole heap of something to maximize, to optimize, and then big words there. Don't want you to get nervous for that. All that sir has been doing with you all is to just use the functions and we work the functions. When you see all of them big words there, I'm going to help you to dissect it. Yes, you have to understand what the question is asking you, but don't be afraid of it. So find a past paper question for me in the meantime. And then we can I can work the question with you and we can say, I want to spend today's class just looking at the real type question because we know how to do the first order partial, we know how to do the second order partial, and we also know how to do the second order cross partial derivatives. So I'm not worried about you guys with those. I know you know. Where I'm a little concerned, if I were to be truthful, is your simultaneous equations. I'm not fully convinced that generally the class knows how to, to solve a pair of simultaneous equations. So I would need to spend a little bit more time and give you more questions so you can develop those. But also I need to get you to a point where we can be able to internalize the questions and to be able to optimize the topic. Or it's a question on optimization. So anybody, somebody, I know some papers were being circulated. I know you have them. Just volunteer and share for me, please.
Sorry.
Thank you.
Most of
Go ahead.
the question look for the critical sorry, I got it.
It's not we're not asking about critical points, so that's why I want you to just share the question and then I can identify the question for you. Share the paper rather and then I identify the question. So it's not when they say find the critical points and so forth. Oh no, it will not say that. All right. So it's like what you see. It's like what you see in this one here, Tariq. Part B. This is a long time question. I want to be. Thank you, sir. I want to spend time to do that one. Scroll for me, please, because that one is easy. Scroll again, please.
This is the last. This is the end of it, sir. Maybe I need to go to the next question.
No one. So no, let me say question 1.
Question 1. Oh wait.
Oh yeah. There you go.
Oh.
There you go. There you go. That's the question. Yes, sir. All of 30 marks. That is a question. So I am going to be going through. We're going to be doing this question today. So this is what I'm saying to you. The question is not going to come and say, find the stationary point, find the first order partial partial. No. The question will be scenarios. You have to unravel the scenarios. Now I want you to come close to the screen. Real talk. A small startup company produces speakers and subwoofers for computers that they sell through a website. So there are 2 items that they sell. What 2 items?
Speakers and subwoofers.
Speakers and subwoofers.
Yes.
So we know when we look at the function pi of xy, we know one of them going to be x and one of them going to be y. What is important at the start of the question is to know which is which. I need to know who is x and I need to know who is y. All right. So we know speakers is one, we know subwoofers is another. So we need to look at what is happening here. The second sentence says, after extensive research, the company has developed a profit function, right? So what happened is, you guys have a computer, you have a computer repair shop, or say you sell cell phones, and you know, say it's either an Android or an Apple, because nobody now use none of them old-time phone there again. Matter of fact, them old-time phone now it's not supported by the system anymore, right? So it's either an Apple or it's going to be an Android. So what you want to do now is to decide, which one I can maximize based on my clientele and based on the extensive research. I can tell you, say, you know what? More clients are coming in to buy Androids than they are buying the Apple. And some other person may say, no, it's the other way for me. And then now we're trying to analyze the stuff and we say, okay, fine. I wonder why. And then one person may say, oh, my store is uptown. And then the other person may say, oh, my store is in Crossroads. So you may say, oh, the uptown people can afford we call it the Apple, and the Crossroads people can afford the Android. So based on your research, you are going to be doing your analysis, and that analysis is going to help you to make a decision. That analysis is going to help you to make a decision. All right. So they came up with a profit function. Pi of xy is equals to x squared y minus 22xy plus xy squared plus 71 thousands. Right? It's in dollars. So anything that you get, if you get 12, how much money are you going to be? Say 12,000.
12,000.
12,000.
Talk to me now. Yeah, man. So it's when it says in thousands of dollars, it means that if you get 12 for your answer, it's not so 12. It's going to be 12,000, right? And then now it says profit. So you will find that production level, that minimize. Minimize, sir? Yes, minimize. So the mere fact that they use the word minimize, it means that you're supposed to be getting a relative minimum. Relative minimum? Oh, I get it, sir. That means when you find f of xx times f of yy minus f of xy squared, the value of f of xx is going to be what? Positive or negative?
Positive.
No.
Positive.
Yeah. Positive. It says minimize. It says minimize. Yeah, man. Positive.
Yeah,
positive. You're right.
Sir.
Positive. You're right. Thanks, Demoy. Positive. Yeah, positive. Yeah, man. Positive. So I'm saying to you, when you read the question, you should be able to know exactly what it is that you're expecting. So should in case you get something that is different from being positive, you know there's something not right with the question and you're going to start over. All right. So do me a favor. The first order of the day is to calculate those 6 partials. Go right ahead for me, please. I give you 5 minutes to calculate those 6 partials for me. Quick and fast. Thank you. All right, I'm seeing a few responses, but there are other responses that I'm looking forward to. So I'm going to be sharing my answers in a few. I'm giving you 1 more minute to finish your thought. 1 more minute. Okay. Um, all right, for the most part. All right. So this is what I'm saying to you. All right. Okay. So tariff and need the other parts of the partial derivatives. Um,
All right, sir.
yeah,
Working on it,
man.
just typing.
No problem. All right. Rayton, I'm seeing your stuff. Yes, the more looking good. All right. Yes, Alvin. I like the look of the first one. You sure that's not supposed to be y squared though? Um, check to see if that's supposed to be y squared in the first part there. Yeah, man. So
Y square, Y exponential too.
yeah, you have it there. So but you sent me. But why did you edit it and change it though? The one before looks correct, you know. Why change it? All right, that's won't come after that. That's won't come after that. Don't do it. Don't do anything.
Okay, sir.
Yeah, the first one kind of look better to me than the second one. All right, this won't come to you. No, no, don't do anything because I don't want to. All right. Okay, tariff. I'm seeing those. All right. Um, Lotarno, I'm not seeing anything from you. Who else? I'm not seeing anything from. Kenneth, Kahim, Shane, Taj, Richards. I need to see some. I need to see some work. But the rest of them, they look okay. I have a little concern about maybe one or two, but I know you guys know how to do your partials. I'm not worried with you about partials, so don't let me get worried about partials. That's why I did what I did with you in terms of spending the time building the partials with you. All right, let me just.
So I just started it. Give me about 2 minutes, sir. I just started it.
Changing the talk. You're joking a bit. All right. My solutions are on another device that I'm going to be either switching over to or trying to log on to. So give me half a second. Let me just see if I can do a fix it over. But I also need to, I think I have done that question already. If I'm not mistaken. And I'm just trying to, okay, I have actually. Zoom now going to over now. One time I could have make a fix it over. And then now it's come over the 993, 993, 933. Sorry, can you just stop share for me, please? Thank you very much for sharing.
Okay, sir.
Did it give me the post? No, it didn't give me the post at all. But I don't understand what's happening. All right, take a minute or two to look at what I have there. All right, how we feel? Are we okay with what it is that I have there? Any questions as to what I have, or we're fine?
All good here.
I think we're fine, sir.
Say it again?
All good
Oh,
here,
you're
sir.
saying something?
Well, I was asking if are we okay with what I have projected there, or you want me to go to that calculation or those calculations? Are we okay with the partials?
Yes, sir. Okay.
Yes, sir.
Okay.
Good. All right. So I hear okay, and I hear the rest of you. Let me ask a question the other way around, because I know oftentimes there's at least one student who is left behind. Is there anyone in the class that is not where we are in terms of the partials? Pi of x, pi of y, pi of xx, pi of xy, pi of yy, pi of xx. Okay, no answer means that everybody is with me. Go ahead.
Sir, could you just run through it, please?
All right. I was going to say something to you before. All right. So one of the things I want you to notice. So what the questions that Sir gave in class, I always give you f of xy. Recognize that the notation is different here. They put pi of xy. That there's a major difference with that.
Yes, sir. Yes, sir.
You think it's a major difference, or is it the same thing?
Yes, same thing,
Sure.
sir.
It's the
No,
same
not
thing.
sure.
It's the
Same thing,
It's the
sir.
same
thing,
It's the same.
sir.
It's the same thing. It's just a different notation. It's just like one name Tarika, one Alwyn, and one name, Raji, and one name whoever else. It's a name.
So the pi don't affect it at all, sir?
No, it's just a name.
Really?
Oh,
Active.
oh.
So I can give you something as sigma, I can give you something as gamma. It's just the name.
Oh.
It's just the name. So don't be alarmed. We have to go use 3.142 and 22/7 and them. It's just the naming of the function. All right. All right. So quickly for and for those of you who don't want to be honest with me, let me just go through this quickly. We're finishing this question today and we're starting a new question, please.
Question when you finish.
Go ahead, Poppy.
I'm saying that I found the next question when you finish.
Okay, fabulous. Love the sound of that. All right, let's go. So pi of xy is equal to x squared y minus 22xy plus xy squared plus 71. So we're differentiating this function with respect to x. So we're differentiating with respect to x, we keep the y constant. So y is going to be constant. I'm going to write y. I'm going to differentiate x squared. I'm going to get 2x. So my answer is going to be 2xy. So that explains this first term. I'm differentiating with respect to x. My y remains constant. So this y is going to be here. When I differentiate negative 22x, I'm going to get negative 22. So my answer is going to be negative 22y. I'm differentiating this with respect to x. That means my y squared is constant. So I'm carrying my y squared. And then when I differentiate x, I'm going to get 1. So it's 1y squared. I'm differentiating with respect to x, but this is a constant. The differential of a constant always equal.
Zero.
Zero.
Zero. So that's why that one there is 0. All right. Continuing. I'm differentiating this same function. Okay, let me go ahead and do xx. So I'm differentiating this with respect to xx. The y is constant up about my y. Differential of 2x is 2. So the answer becomes 2y here. Differentiating negative 22y with respect to x, that is a constant, sir, but it has a variable beside it, yeah, but the variable is not x. So once the variable is not x, it's going to be a constant. So that goes to 0. Similarly, there is no x here for the y squared, so that also goes to 0. All right? So these are my first order partial with respect to x, and my second order partial with respect to x. Now I'm going to go to my first order partial with respect to y. I'm differentiating with respect to y. It means that my x squared is constant, so I'm writing about my x squared. Differential of y is 1, so we have 1x squared. See it right here? Sorry, if I put the 1, I don't have to. I'm differentiating negative 22xy with respect to y. So it means that my negative 22x is a constant, so I write back my negative 22x, and the differential of y is 1, so my answer is just going to be negative 22x. I'm differentiating x squared y, look, xy squared with respect to y. The x is a constant, I put it back, see it right here. But when I differentiate y squared, I'm going to get 2y. See the 2 here and the y here, so I'm going to get 2xy. And the differential of 71 is still a constant, so it goes to 0. And then when I differentiate y with respect to y again, in order to get y, I'm going to, x squared is a constant because there is no y. So is negative 22x a constant because there is no y? Here goes a y. So because I have this, my 2x is going to be a constant. So I put back the 2x and differentiate y. The differential of y is going to be 1. So my answer is just simply 2x. Then I'm going to be differentiating now my cross order partial, my second order partial, cross order partial. Let me pause. Can you, Mario, okay?
Yes, sir. I'm fine.
The rest of you, are you okay?
Yes, sir.
Yes, sir. We're
Yes, sir.
okay.
Yes, sir.
Good job.
No,
So,
no, sir.
what happened?
No, sir, not the truth. No, okay.
You know, it thinks I don't know. Because when I ask question
Sir?
and I hear it, I think I don't know.
No, I'm okay, but I'm not for the class today. Otherwise, Mr. Tell me okay.
Sir.
I'm just very concerned. I'm just very concerned about your silence, you know, because I don't know if everything is all right. So should I be worried or are you fine?
No, sir, by later, I have a good friend who can check me, but so by later I'm supposed to be all right.
Okay. Make sure. Okay, no. So in my second order cross partial. Why are the cross order partial? You notice I have x and y. It's second order because I have two terms on here, so. Second order because there's two terms on here, so. Second order because it's two terms here, so. First order because it's only one. First order because it's only one. Second order because it's two. So this is my first order cross partial. First order cross partial. First order cross partial with respect to x. First order cross partial with respect to y. Second order partial with respect to x. Second order partial with respect to y. Second order cross partial with respect to y. Second order cross partial with respect to x. All right, so let's go. It means now that it says pi xy. I'm looking at pi subscript x, and I'm differentiating with respect to y. That's how we get the cross order partial. I'm differentiating this one with respect to y. So it means that my x is a constant. So I'm going to put back my 2x because my 2x is a constant. So I'm putting back my 2x. See it right here, so? And then I'm differentiating y. When I differentiate y, I get 1. So it's going to be just simply 2x. See it here. I'm differentiating this with respect to y. So negative 22y now becomes negative 22 flat. See it here, negative 22. Differentiating here with respect to y. Differentiating y squared with respect to y. It becomes 2y. See it here, 2y. Now I'm differentiating my y with respect to x. Differentiating x squared with respect to x becomes 2x. See it here. Differentiating this term with respect to x, it becomes negative 22. See it here. And differentiating here with respect to x, it means that my y is constant. So I'm going to put back my y and differentiate 2x. I'm going to get 2, so the term is going to be 2y. Always remembering that your cross order partials should always be equal. Your cross order partials should always be equal. Pausing. Any questions? Quick and fast. Yes or no?
No, sir.
Okay, let's
No,
move.
sir.
Now, remember, what it is that we're supposed to be doing is to solve. I'm reaching out to the question, I know. Remember the question now. So even before you understand what the question is asking you, even before you understand what the question is asking you, you can go ahead and do your 6 calculations. Because you can know that you can use your 6 calculations in order to answer the other parts of the question. Other parts of the question, it says to find the production level that minimizes the profit. But there are several things that we need to do. And it did say minimize. All right? So let's go. So we're solving simultaneously. What we use to solve the simultaneous equations, what we use for 2 equations are going to always be my first order partial. Please do not use any other than the first order partial. The f subscript x of xy, f subscript y of xy, or pi subscript x of xy, or pi subscript y of xy. We're using the partials for x and y. So technically, I'm setting these 2 equations in blue to be equals to 0. See them here? And I'm naming one my equation 1, and I'm naming the other my equation 2. I'm naming one as my equation 1, and I'm naming the other as my equation 2.
Sir,
Go ahead.
I rearranged it. Well, I'm not so sure if that's what you're gonna do, but just like in equation 1, we have the 2xy first. So in equation 2, I rearranged it and put the 2xy first, and we could minus any one from the other. That's what I did, to subtract one from the other to get rid of the 2xy. But that's where I stopped, basically.
All right, no problem. I see where you're going. But if you subtract the 2xy from both equations, it means that you have to go subtract the 22y, the negative 22y from something. But which one of the terms will you subtract the negative 22y from?
Well, that doesn't exist.
So you see my level of reasoning now? Why I ask the question the way I ask it?
Yes, sir.
Because this equation now, so you notice I say here we're solving simultaneously. This simultaneous equation cannot be solved using the elimination method. It's solved using the elimination method. Why? Because both equations are nonlinear. So the only way we can use the elimination method is to have 2 linear equations. So we now have to solve here using a different approach. So I am going to grab one of the equations, and I grab equation number 1. As I said to you when I was introducing the topic, sometimes you have to grab one equation, work it independent of the other equation, and then substitute it into the second equation. Anybody remember me saying that?
Yes, sir, I did.
Yes, sir.
Yes. So we have to be very mindful of that. Getting working it independent of the equation, and then go ahead and do our substitution. All right, so let's go. So I'm using my equation 1. And what it is that I did, I am making 2xy the subject of formula. I'm making 2xy the subject of formula. So it means that everything else needs to be on the other side. So I'm going to add 22y to both sides. That means over here it becomes positive. And I'm subtracting y squared from this side. So you're going to have a negative y squared. Can everybody see this line?
Yes, sir.
Yes, sir.
All right, good. And I want you to follow me, I want you to follow exactly what it is that I'm doing. And then what I'm going to be doing next, I'm going to divide both sides by y. I'm dividing through by y. So I try to color code it so that I can demonstrate it a little better. I'm dividing both sides actually by 2y, because what I want is to keep my x alone on one side, because I'm going to use my x now to substitute it into the other equation. So I'm dividing both sides by 2y. So 2y over here, see there? And then all of this is going to be over 2y. The 2's cancel, so does the y. So now I'm left with x alone on this side. Can you see that?
Yes, sir.
Then now I have 22y minus y squared over 2y. Who said this to me the last time? Andrew. Is Andrew Smith here? Andrew not here. All right. So Andrew said something to me that, sir, just cancel it out now? No. Canceling at this stage of mathematics becomes abominable. Because when it cancels, sometimes you're throwing out some answers. So we're going to factorize. So what is common to the numerator, 22y minus y squared, would be y. Can you agree with that?
Yes, sir.
So y. Now look at what happens. Now that I've done a factorization, I can now go ahead and do a cancellation. So I can now cancel the y's. So I'm going to be left with 22 minus y over 2. And that cannot be simplified any further. Sir, yeah. Why don't divide the 2 into the 22 and get 11? Okay. But this one again have minus y over 2. I don't want that. So I'm going to leave it at this. So my simplified form, go ahead. Go ahead, Shano.
Oh, sorry, sir. Whenever I realize my mic open.
Oh, okay. So what is happening here now? I am going to substitute this. Guys, hear me out. Which equation I started out with here?
Equation 1.
Can I substitute it in equation 1 now?
I'm gonna have to use equation 2.
I have to use equation 2. I can't substitute it. The equation that I worked with to simplify, I have to now substitute it into the other equation. I have to substitute it into another equation. I cannot substitute it in the same equation that I have worked out. Remember we said simultaneous? Simultaneous means at the same time or together. So the method of simultaneous that we're using here is called the substitution. I am substituting one equation into the other. So anywhere in the function I see x, I'm going to substitute 22 minus y over 2. Anywhere in the function I see x, I'm going to substitute 22 minus y over 2. Watch me. The second equation is pi by y. See it here? I recall it here for you. So anywhere in this equation, let me bigify this somewhat in the event that you're using your phone. Anywhere in this equation, I see x. I'm going to substitute 22 minus y over 2. X squared is going to be 22 minus y over 2 all squared. Minus 22 times 22 minus y over 2 plus 2 to x here So it's 2 times 22 minus y over 2. And I have to carry back this y right here and put it back here. So tell me if you agree with my substitution to get rid of all the x's right here.
Yes, sir, I agree.
All right, good.
I agree, sir.
Good, great. So watch me now. I'm doing a little side calculation. That's why I asked you to take note. I'm doing a little side calculation. Remember, not 30 marks for the question, you know. Don't expect it then to be 30 easy marks. Topic in and of itself is not hard, but you have to work for the 30 marks. Watch me. This 22 minus y over 2 all squared is the same thing as 22 minus y times 22 minus y over 2 times 2. Watch me. 22 minus y over 2, you're going to write it 2 times. You can have 22 minus y over 2 times 22 minus y over 2. See it here? So one of them here, and see the second one right here. So tell me that you see that.
Yes, sir.
Guys, when I'm asking the question, I must answer now. I keep hearing the same people asking me. If you're not seeing it, and I don't want to reach another question, I say, oh, I don't understand everything. On your own. So as I explain the question, just work with me, and let me explain the stuff at that time. All right, let's continue. I am going to be distributing 22 minus y all over this 22 minus y. So I'm expanding my bracket. I am expanding my brackets. Watch me. 22 times 22 is 484. 22 times 22 is 484. Watch me. 22 times negative y is negative 22y. Now that I've used this 22 to distribute over this parenthesis, I am now going to be using negative y to distribute over the same parenthesis. Negative y times 22 is negative 22y. And negative y times negative y is a positive y squared. And 2 times 2 is 4. So let me fix it up now. 484 is a standalone. I don't have anything to combine with it. So I'm going to write back my 484. Negative 22y minus 22y is going to give me negative 44y. And y squared is simply y squared. Follow me?
Yes, sir.
Yes, sir.
All right. So now, if I were to evaluate all of these now, I had to use the side note first because I have a square term here. So look at what teacher is doing. I am now substituting this 22 minus y over 2 all squared with now 484 minus 44y plus y squared over 4. See it right here, so? So this is that. Watch me. 2 into itself at one time, 2 into 22 goes 11 times. See that?
Yes, sir.
So I now have negative 11. See it right here, negative 11.
times 22 minus y, see it right here. This 2 cancels with this 2, so all I'm going to be left with is 22 minus y. See here? 22 minus y. But remember, don't leave out this y that is right here, so that y has to be carried back right here, so. And this is equal to 0. Now look at what teacher is doing. When you look at this equation, all of this ugly stuff, what's the LCM in this equation?
Sir, 22?
LCM, sir.
4.
4. 4. So in order to get rid of the 4, the LCM, in an equation, I can multiply through the equation by the lowest common multiple. In order to get rid of the fractional forms, I can multiply the equation by the lowest common multiple. When I multiply by the lowest common multiple, magically the fractional forms will disappear. And that's why I have times 4 right here. So I'm saying this because I don't want anybody to know, run, go and say, oh, I have to multiply by 4. No. If the LCM is 10, you'll multiply this by 10. The LCM is 15, you'll multiply by 15. You're multiplying through by the LCM so that you can cancel the fractional form. So this is what I now have. When I multiply this by 4, this one cancels out. The 4 cancels this 4. So I'm going to be left with 484 minus 44y plus y squared. And guys, this question is rough. And I'm taking my time to go through the question. So therefore, I would expect if you're not following something that you will stop me. You guys are mature enough. This is now your second semester of this calculus course. I know the question is rough and heavy, and it contains lots of algebra. Yours is the responsibility. Sir, I'm not following right there. Wait until I done the question. Then you can say, sir, I don't understand anything because I'm not going to go through the whole question again. I'll be able to go through sections of the question to explain. Right. But when I multiply throughout the equation by 4, it is each term in the equation that is going to be affected by this multiplied through by 4. How many terms do we have in this equation? Can somebody tell me how many terms I have in this equation here? How many terms do I have?
It's 3, sir.
3.
Very good, Alvin. Excellent, Papa. Proud of you. I can buy you the rum. Very nice. So this is one term. The terms are separated by my addition sign or my subtraction sign, not the multiplication sign. My addition or subtraction signs. So for this term, I'm going to multiply by 4. See here? Boom. 4 times all of this. Then I'm also going to multiply 4 by all of this. All right?
Sir, or when I multiply the first part by 4, it cancels out.
Yes, because that was the LCM. Very good.
Because, yeah.
That was the LCM. So 4 into 4 cancels out.
Yeah, so that part of the fraction contains the 4. Remember,
Right.
say on one side, you on the other side, the equal sign.
Right. Right. And then, of course, based on what Alvin just said, I have to multiply the 4 by the 0. And 4 times 0 is 0. So that's why you're not seeing this 4 here again. So now BOMDAS says brackets of multiplication and division before addition and subtraction. So I have to now go ahead and do a multiplication of my brackets. This first term is already okay because there are no parentheses right here. But these two terms have parentheses. Uh-oh. But sir, there is a parenthesis and an inner parenthesis. Okay. Thank you for recognizing that. That my square brackets also represents a bracket, and my curvy brackets are the ones that you are accustomed to. But my square brackets are also referred to as brackets. So I'm going to work inside first, and then I work outside after. You notice this 4 I carry back right here, so then I'm going to work the inside. 11 times 22 is 242. Check that for me, please. 11 times 22 is 242.
Correct.
Yes, sir.
Good. And then 11 times negative y is negative 11y. Can you see that?
Yes, sir.
Good. Similarly, this 4 is this 4. But where on here, so you have a y. Y times 22 is 22y. And this y outside here times this negative y gives me a negative y squared. Go ahead, Alvin.
Nothing, sir. Nothing, sir.
Oh, okay, got you. So what it is that I've done is to just to expand the inner parts of my calculation. Inner parts of my calculation. So I now need to expand the outer parentheses. Remember, not because these are square brackets, it means that you're not supposed to multiply. Watch me. 484x, lies. 484 minus 44y, it's right here, plus y squared, negative 4 times 242 is negative 968. Negative 4 times 242 is negative 968. And negative 4 times a negative 11y. When I multiply two negative numbers, I get a positive number. So it becomes positive 44y. See it here? Positive 44y. Similarly, 4 times 22y will give me 88y. See it here? 88y. And 4 times negative y squared gives me a negative 4y squared. See it here? Negative 4y squared. So now that I've removed all my parentheses, I can look to see if there's anything that I can cancel. Yes, sir. I have a negative 44 here. Y. And I have a positive 44y. I can cancel those. And then what I'm saying to you that I'm doing here is putting the like terms together. So I'm going to have 484, see it here. Then I'm going to have a negative 968, I'm putting it here. Then I'm going to have a 88y, I put it here. Then I'm going to have a y squared, I put it here. And then I have a negative 4y squared, I put it here. One of the things that I normally do right here, guys, is to count how many terms I have. 1, 2, 3, 4, 5. And I'm coming down here and I'm going to say 1, 2, 3, 4, 5. I do this to ensure that I've not missed a term. Now, watch me. 484 minus 968 equals what?
Negative 484.
484. All right. I guess I was tired when I was doing this for you guys. To the point I left out, I skip a line or two. So what I'm going to do because I'm going to send you, this is a long question. I'm going to send you this workout. So I want it to be as simplified as possible. So I'm going to write it. You said negative 484, right?
Yes, sir.
So negative 484 plus 8y. And this is a minus 3y squared on.
Yes, sir.
Now, agree with me that we normally, how do I say this, Lord? All right, so I can work my trinomial with a negative y squared coefficient. But normally, our y squared, we want our first term to be positive because it becomes a little tricky. It becomes a little tricky. So what I'm going to do is to multiply. I'm going to be multiplying my equation by -1. So why? So that I can get rid of the negative y squared. Then sure enough, when change the equation, no, because I'm multiplying throughout the equation by that scalar quantity. Similar to how we multiply through by 4, we're not changing it. So I'm going to multiply through the equation by -1. I'm doing this because I'm. Go ahead.
So Richard, sir, I'm telling you what I do. I carry constant across the equal side.
Same difference.
And then factorize.
Same difference, Papa. Right? So you could use the additive. I understand when they say carry over, I don't like the term carry over, but I know what you mean. But you know, you're transposing.
Yes, sir.
Good. Or transpose. Very good, though, Alwin. So I could also transpose. So what I'm going to get now is positive 3y squared minus 88y positive 484 equals 0. Do you agree with that?
Yes, sir.
Yes,
Let me show you what let me show you what Alwin was saying here. Alwin was saying, sir, what I will do, you know, when I get this negative 3y squared, I just transpose it, and over here it will become positive 3y squared. See it right here, so boom. And Alwin is saying, sir, this positive 88y, when I transpose it to this side, it's going to become negative 88y. See it here, so negative 88y. And sir, this negative 484 on this side, when transposed over here, it's going to become positive 484. See it here? Same difference. So I can either multiply through by the negative 4 to rationalize my function, or I can transpose. Same difference. Now this is what I must be able to factorize. So the question don't finish. I don't finish the question yet. Now, from calculus 1, I've showed you how to factorize using your prime factors, your prime factorization. We have to use the prime factorization for this question. And look at what we're doing. We are multiplying 3 by 484. When I multiply 3 by 484, what do I get?
$1,452.
1,400 who?
452.
1,452. I got that correct, right? 1,452?
Yes, sir.
Yes,
All right,
sir.
good, thanks. Good, thanks. So I'm prime factorizing. I'm prime factorizing. So when I prime factorize, I'm going to be using only prime numbers, duh, because it says prime factorization. What is my first prime number? Say it again. I multiply the coefficient of y squared by the constant. Multiply the coefficient of y squared by the constant. Huh? Are you seeing that now? Okay, good. So the first prime number is?
One, sir.
If I take away your lunch money, you see? One is not a prime number. A prime number has exactly two factors, itself and one. A prime number has exactly two factors, itself and one. What is the first prime number?
The first one would be 3, sir. Would it?
Sir.
Yes,
2.
please. Thank you very much, Alwyn.
2, sir.
A prime number has exactly two factors, itself and one. One cannot be a prime because the factors of one or the factor of one is just one. So the first prime number is 2. The only prime number that is even. So the first prime number is 2, and 2 is the only prime that is even. Let me just go off track and answer a question. If the number is not prime, it is known as a?
You're breaking up. Repeat what I said, sir.
If the number is not prime, what is the opposite of a prime number?
A composite number.
Composite, sir.
Very good. It's a composite number. And a composite number has more than? More than two factors. Very good. All right. So a composite number has more than two factors. A prime number is the opposite to a composite number, and a prime number has exactly two factors, itself and one. One is not a prime. The first prime number is 2. The only number that is even, only prime number that is even. Fair enough?
Yes.
Yes, sir.
So let us go now through this calculation. So 2 into 452, no, 1,452 looks like 726. Talk to me.
Yes, sir.
Yes, sir.
Good. And I'm thinking that 2 can go into 726 one more time as 2, 3, 6, and 1, 7. 2, 6 is 12. 2, 3, 2, 3, 6, 3.
Yes, sir.
Yes, sir.
Good. Can 2 go into this?
No, sir.
No, sir.
Why? How you know that?
Because 3
As it-
is the odd number.
There are 2 3s, sir. Which of the 3s?
Sir, the
The
3 at
last
the
3.
The last 3. Very good. So how I know that 2 is divisible by, sorry, How I know that 1452 is divisible by 2 is because the last number is
An even number.
very
Two.
good. I thought you were going to say 2. Excellent answer, Damoy. So the last number is even. So you know that it's divisible. Not because it's 2. Because had it been 0, do you know that 0 is an even number?
Yes, sir.
Yeah, man. 0 is an even number. So any number ending in 02468 are classified as even numbers. And any number ending in 13579 are classified as odd numbers. So 0 is an even number. So I'm going to try 3.
120.
3 into 3, go 121. Agreed?
Yes, sir.
Can I go 3 again?
Yes, sir.
Yes, sir.
I
Really?
don't.
No,
No?
sir. No.
No.
Oh, can I use 4?
No, sir.
Why?
Because it's not a prime number.
It's not a prime
Very
number.
good. It's a composite number. Can I go 5?
No.
No, sir.
No. And I'm not, I
no,
can't
sir.
even call 6 because 6 is composite. Can I go 7?
No. No, sir.
Can I go 8?
No, sir. You can't do it.
No,
Can I
sir.
go 9? Because 9 is an odd number. So 9 is prime because it's odd down.
No,
No,
sir.
sir.
Nine.
No, sir. No, sir. Sir, 9 is not a prime number.
Why?
Sir,
Because
because
9 has
Because it has
three,
3
three,
factors.
yeah.
Really? Is it 3 factors 9 has?
Sir, 3 or 2? No, 1. Wait.
1, 3, and 9.
Very good. So the number is the number is a factor of itself. Excellent. So, and I can't use 10. Can I use 11?
Yes, sir.
Yes.
Good
Yes,
job.
sir.
And 11 into 121 goes
11 times, sir.
11
11
times.
times. And then
11.
I'm going to go 11 once more. So what I'm going to be doing here now, watch me carefully. I'm going to be manipulating my prime factors in order to get negative 88. I'm going to tell you a secret. When I look at my trinomial, do you agree that 3x squared minus 88y plus 484 is a trinomial?
Yes, sir.
Why comes?
That has 3.
Okay, good job. Good job. So it has 3 terms, right? So it's a polynomial, but just like what we have like a quadrilateral and we have several different types of quadrilateral, square, rectangle, rhombus, kite, trapezoid, so forth, and so we just call them quadrilateral because they're all 4-sided figures. We have some polynomials that we can give more specific names. All right. So we can give it a binomial, we can give it a mononomial. We can call it a binomial. We can call it a trinomial. But we ain't got to know quaternomial and them. No. You see, once it reach a trinomial, we just say, oh, polynomial. All right. So a mononomial is also a polynomial. Right? But we don't really call a mononomial polynomial, even though it is by definition, because once we speak about poly, we're talking about many terms. All right. So once it has more than 3 terms, we just call it a polynomial. But yes, recognize that a mononomial is a polynomial, the binomial and the trinomial. So we have a trinomial. So I need, when the last number, this one here, is a positive sign, it says that the factors are going to be one positive and the other one negative. Sorry. Let me go again. I was looking at a different thing. When this sign here is a positive sign, it says to us that both signs in the brackets are the same and they look like this sign. So both signs are going to be negative. Sir, say it one more time. When I'm factorizing, and the last sign here, this positive sign, it's a positive number. It tells us that both signs in the brackets are going to be the same number, and the two signs are going to be negative. Why, sir? Because it takes the color of this sign, and because the sign is negative, it's going to be negative. If this sign were negative, then one of them going to be positive and the other one going to be negative. All right, so let's go. We're manipulating. 11 times 3 is 33. I'm going to write it down. So I'm going to say 11 times 3 is equal to 33. This 11 and this 3, I get 33. And then I'm going to have 11 times 2 is 22, and 22 times 2 is 44. So I'm going to have 44. No, when I add 33 and 44, do I get 88?
No, sir.
No, I don't. So that can't work. But if I say 3 times 2 is 6, this 2 times this 3 is 6, and 6 times 11 is how much?
66.
66. And then I'm going to have this 2 and this other 11 left. What is 2 times 11?
22.
22.
All right. So 66 and 22 will give us 88.
Yes, sir.
Yes, sir.
So we have found our factors, right? And to be honest with you, from the first look at those prime numbers, I could have told you the prime factors. But what I did was just to go through one that I know is not the prime factor so that you can see how it is that we manipulate those numbers. So once it is that you prime factorize correctly, you can use your prime numbers in order to get your answer.
Sir,
So I know, go ahead, sir.
sir, when the part again, the last part, the 66 plus 22. Look at that.
All right, no problem. Happy to share with you. So I'm using this 2 times this 3 to give me
6, sir. Yes, sir.
and 6 times 11.
Oh.
So I'm using these, I'm multiplying these 3 numbers to give me 66.
Yes,
Can you
sir.
see that I have only 2 set of numbers left?
Yes, sir.
Right, so, and 2 times 11 gives me 22.
Okay, all right.
But because of this little saga up here, so I know that both numbers are supposed to be negative. So I'm going to have negative 66 and negative 22, and the pair of those numbers will give me negative 88. When added and when multiplied together will give me positive 1452. So 66 times 22 is going to give you 1452. Double check for me, please, just to convince yourself, because I know I'm correct. What is 66 times 22?
You're correct, sir. 1452.
1452. All right. So it's supposed to work both ways. When you multiply it, you're supposed to get your product. And when you add it, you're supposed to get your middle term. All right. So watch what I'm going to do now. Now it is that I can go and do my factorization. So I'm going to say 3y squared minus 66y minus 22y plus 484 is equal to 0. You see what it is that I've done? I have broken up my negative 88y into negative 66y and negative 22y. Then I'm going to group, and all of this we did in calculus 1, but I'm reviewing it. I did this in calculus 1 when we're looking at stationary point of the single variable function. So I'm going to say 3y squared minus 66y in one bracket. Leave the middle sign out every time, but when the middle sign is a negative sign, you have to say Mr. Negative, because something goes wrong with that. What sign goes in this little piece here?
Negative.
Negative sign. When this sign here is negative, in the middle here, I must flip this last sign. And in flipping this last sign, it's going to become a negative sign. Similarly, whatsoever sign that is in this parentheses has to be the same sign in this here parentheses. Both signs must be the same. Both signs must be the same. What is common here? 3y squared, that is common to negative 66y.
Sir.
Huh?
3y.
3y, correcto. What is left?
Y minus, that's 22.
Y minus 22. Good job. What is common between 22y and 484?
So 22.
Good job. What's left?
So it's to be y.
Minus 22.
Y minus 22.
Y minus 22. Okay. Y minus 22. So what is common is going to be y minus 22 times 3y minus 22 is equal to 0. And that's what I got. 3y minus 22 and y minus 22. So I can pick up from there. I didn't do that part because we did all of those calculations already in calculus 1. So I left out that portion. Now that I've done it, we can pick up from where we left off. Any questions so far before I continue?
No, sir.
All right, let's continue. Alvin, are you still there? Not hearing you.
Yes, sir, I'm here, sir. So no questions.
Okay. Thought to drop asleep or drinking rum.
No, sir.
All right, let's go. All right. So now, continuing from here, I'm going to say, either. Okay, what is that? Something is happening. All right. Okay, good. So let me go back to my spotlight. It's a long question for 30 marks. So either 3y minus 22 equals 0. Let me show you what is happening right there. So either 3y minus 22 is equal to 0. So therefore, 3y is going to be equal to 22. Divide both sides by 3. Y is going to be equal to 22 over 3. And that's why I got this one right here. 22 over 3. And this one is simpler. If y minus 22 is equal to 0, it implies that y is equal to 22. Got me?
Yes, sir.
What are these two values called?
22 to be exact,
Y equals
sir.
22 over 3 and y equals 22. What we call those two values?
Critical points.
No, critical
Values.
Values.
values, right? Critical values. When I substitute now
You get
into
critical points. Yes, sir.
very good, I get the points. Very nice, very nice. So let's go. So remember, we had simplified one of our equations. Let me just go up top here. X to be equals to 22 minus y over 2. I'm recalling that here. X equals 22 minus y over 2. I have two values of y. I'm going to substitute these two values of y into this function. Then, sir, what if I wanted to substitute it in equation 1 or equation 2? You could. But look how ugly equation 1 and equation 2 look. When it is that you have already simplified those equations, or simplify one of the equations to look more simplified. So I'll go ahead and use this one. So I'm going to put y equals 22 over 3. And when I do that, this is what I'm getting. 22 minus y is 22 over 3, 22 over 3 over 2. So I'm working on the numerator. If you have your calculators, you can just go ahead and put everything one shot in the calculator. Let me walk you through that exercise now, because some people think to me, sir, I don't see this. So let me walk you through that exercise. Clear your calculator for me, please. I will still do this, but I want you to clear your calculator for me. Clear your calculators, and then you're going to press 22. 22 minus, open bracket, 22 ABC3, close bracket, equal.
Repeat that, sir.
Say that about 3.
Sir, repeat it, please.
It's 22 minus open bracket
22.
ABC 3 close bracket.
Sir, I have to do that again, sir. I calculate the upgrade.
Yes, I. Tell me your answer now, man.
What? What? You said, 44 at 3.
You get 44 over 3. Very good,
Yes,
and that's
sir.
correct. 44 over 3. And that now is divided by this 2. Divided by 2. Remember, it's 2 over 1. So this is going to be the same thing as 44 over 3 multiplied by 1 over 2. Because when you have to multiply, invert and multiply. So I'm going to get 44 over 6. See it here, so? 44 over 6. And when you get the 44 over 3, see, don't clear the calculator. I hope you didn't clear it. Don't clear the calculator.
Sir, my calculator give me 22 over 3.
Yeah, man. May I want to? See it right here, so? When you simplify it, you get 22 over 3. Same difference. All right? All right, let's move on. I also must, so my critical value here is going to be x is 22 over 3, comma, y is going to be 22 over 3. So x and y have the same value. So one of my critical points would be x 22 over 3, comma, 22 over 3. Now I need to find the other critical point, not critical value, but critical point. I need to find the other critical point. Y is equal to 22. I'm going to substitute 22 over here. Uh-oh, look at that. 22 minus 22 equal?
0.
And 0 over 2 is?
0.
0. So that value is going to be 0, comma, 22. Are you agreeing with that?
Yes, sir.
So 0, comma 22, and 22, comma 22 over 3, comma 22 over 3. Right? Question still don't finish yet. It may seem long because I'm explaining as I go along, but it really isn't that long.
Sir, this question is supposed to determine if you pass the exam or not. It alone is good.
And that's why I'm saying to you, I'm preparing you. So long I'm on multivariable function, I don't, and to be honest with you, I have to move very quickly from this, because the multivariable functions is the longest. I don't touch Lagrange yet. And I'm expecting Lagrange to come. Lagrange normally come for about half as much as this. So I'm expecting Lagrange to come. So immediately after I finish this, so you better learn this quicker for us. Because for sure by next week, Monday, God's willing, I want to be able to move into Lagrange. What am I saying? This week I want to finish off this topic. All right, so let's go. So I have my critical point. Now we need to classify. I have 2 values. We need to classify. Now remember, the question did say to us that we need to do to find a value that minimizes the profit. Let me remind you what the question says. The question says, find the production level that minimizes profit. Now, once I'm saying minimize, my headspace starts to run. F of x times f of y minus f of xy all squared. In order for me to minimize, it means that d must be positive. And in order for me to find a local minimum or a relative minimum, my f of xx must also be positive.
Yes, sir.
If my f of xx is positive, if negative, it's going to be a maximum. So I'm expecting f of xx to be positive. Watch me. If when we reach right here and f of xx is not positive, we know we're wrong. So as it goes through the question, make the question make sense. Uh-oh. Is f of xx positive in both cases?
Yes, sir.
Good. So we know that we're on the right track. right? So as you're doing the question, students, make the question make sense, no? Make the question make sense. All right, let's go. So we know what, so we have to calculate the, in order to obtain our relative maximum or relative minimum. And I'm going to show you a point here. So I'm going to use the easy of the two first, because boy, a pair fraction I work with, and I need to kind of ease up my headspace with. So I'm going to use the 0.22 first. I'm recalling what my f of xx, f of yy, sorry, my pi of xx, pi of yy, and pi of xy to be equal. Then I'm going to substitute into my function, my determining function there. F of xx is 44, f of yy is 0, and f of xy is that. Sir, oh, you get that? So we never get that before. All right, thanks for asking. This is 2 times y, but y is 22. So 2 times 22 gives me 44. Y is 2x, but x is 0. See here, so? So 2 times 0 is 0. And xy is all of this. But x is 0, so that means that the one you go 0. And then y is how much? 22. 2 times 22 is 44. Negative 22 plus 44 going to give me 22. So that's why I get the 22 right here. So, with me?
Yes, sir.
Yes, sir.
So watch me now. So it's going to be f of xx times f of yy, f of xx. 44 times 0 is 0. Minus 22 all squares. 22 all squares is 484. But you have a minus sign that separates it. So these negative. So once these negative, it tells us that we have a saddle point. See here? It don't make sense to do nothing more. Once you get D to be negative, it's a saddle point. Once D is positive, it tells us that we have either a relative maximum or a relative minimum. And then we have to check now our f of xx value. And if our f of xx is positive, it says that we have a relative minimum. And if f of xx is negative, we have a relative maximum. All right, so we have to know this before we wait to the exam. It's not going to be given to you. So you must know this, guys. You must. All right, let's continue. So we know we have a saddle point for here. Finally, the final part of the question now is to check out these. 22 over 3 is y. So 22 over 3 times 2 is 44 over 3. See it here, so? Y is going to be the same thing because it's 2x, but x is 22 over 3. So 2 times 22 over 3 is going to be 44 over 3. And let's just check xy. Trust me, when you do all of this, you can get 22 over 3. So these are my values. And now I'm going to be f of xx times f of xy, 44 times 44 is enough. See it here, 44 times 44 over 3. We're going to give me 1936 over 9 minus 22 over 3 all squares. I'm going to do all of that calculation. I come back with my 1452 over 9, which is a positive number. So if it is positive, I don't know if I have a relative maximum or a relative minimum. So I'm going to go ahead and check. If is f of xx positive? Yes, sir. So I have a relative minimum. But guess what? We didn't know say a relative minimum long time. For me, read the question before me even start. The question says to me that I must do something to minimize production. Whatever I do, I must minimize my production. And if I don't minimize my production, I'm going to be in problem. And I'm going to explain to you what I mean by minimize. I just want to make sure that I finish this so that time don't run out on me with this question. And then, that's it. That's it. Now, let me just explain something to you about this whole minimize business. Don't know how many of you here are parents or are older siblings and have to shop for argument's sake for your younger siblings, or could be a nephew or a niece. But yeah, but or just a consumer. Yeah, we're going to like a Foot Locker for argument's sake. And you look and you say, yeah, you're trying to find a shoe for yourself or a toddler or a youth. Don't you see more adult type shoes than you do like a toddler shoe, pair of shoe? Yes, no? Anybody observe that?
Yes, sir. Yes, sir.
But maybe that's not a good example because the rest of them don't say yeah.
Sir, because there's like a section for everybody. So you check unless you're going to buy from child.
No, but you walk into the store and you can see it. You walk into the store and say, oh, that is the baby section and look with her shoes right there. All right. The point I'm making though is whenever you're in production, you're trying to minimize your production cost. You're minimizing your production cost. And the reason for argument's sake, why you're not seeing many of, you may see 20 pairs of size 8, if not more, on the shelf. But you may see only 2 pairs of toddler 4. Because the shoes there for the babies are so intricate. It takes so much more to manufacture. The finer details, etc., etc. So it's more money to produce those. Because I'm going to tell you, the cost of one of those baby shoes, you put on a little change more on it, you can get the cost of your shoe. It's expensive. So the manufacturers are saying, yo, I am not going to be manufacturing many of these shoes because one, it costs too much to manufacture, and you may not have the sale on it. So if you're going to pick up a Nike, chances are you may walk in and you can come out with 2 pairs of Nike. But chances are you're going there to buy a shoe for the toddler. You're not going to want to buy 2 pairs because 2 shoes the toddler then throw it out. True or false?
True.
Yeah, man. So you will keep your shoe longer than a toddler does. So you may see value for money. So you may go and spend $150 and buy a pair of sneakers for yourself because you know you can keep it for years. But for you to go and spend $99 to buy a toddler 4, I know, say, in a month or 2 or 3 months, that can't work again. You don't want to do that. So this is a practical example of manufacturers minimizing production cost. Real talk. I am not going to be manufacturing bangers. One of the things that, well, the bangers are no longer supported on the network. Don't know if anybody here works with digital or flow. So the bangers are no longer supported. But guess what now? They have to recognize that you have some of their consumers that are not sighted, and them can't see if you touch a smartphone. So they are going to use, they need one of those regular phones with the race key. So those who are visually impaired can actually use the stuff. So those phones are being made now because the bangers are no longer supported on the networks. But those phones that are now made are now smart. So they have the smart bangers now. That's the point I'm making. They have the smart bangers. But guess what? Not many people will go to the store to buy a smart banger because many more people are sighted than are not sighted. And if you are going to go on and stock quite a bit of smart bangers, you may be stuck with those smart bangers for quite a while. So you're minimizing your production cost so that you're able to have more phones. Because remember, you know, you're going to have only X amount of money to go and stock up your store. So when you stock up your store with a product that is not being sold, you're going to stick longer with that product. And this is why some of the companies, again, when they do, you know, it's one of my pastimes. There are days I'm at school and I say, you know what, it's lunchtime, let me go and have lunch. And I will just drive down to New Kingston and go to La Shushan. And when I go to La Shushan, I say, okay, fine. You know, it's going to be yogurt for lunch today. And I go to the fridge and trust me, 9 out of 10 times I'm going to the refrigerator, you will see sometimes they ban 2, 3, or 4 yogurt for the price of 1 because the expiration date is fast approaching. It's not a problem. It's in the middle of the day. I can't keep it to carry it tomorrow. It's going to go bad. Worse like this, almost at the end of its expiration date. So I may say, you know what? I buy 4, I'm going to eat 2. I'm going to find 2 co-workers and say, yo, you eat lunch already? Eat. Say 2 yogurt, go and go wash it down, or give 1 and find somebody 1. Because it's not costing me anymore. But you're saying no, but sir, it will cost them Lashushan. No, it doesn't. Because if they are going to buy yogurt to sell, and they're not going to buy 1 case of yogurt. It's a big supermarket. Chances are they're buying 12 cases of yogurt. Because they're minimizing their production cost to a sense. Every 3 packs of or cases of yogurt that they sell because of their markup, they make back the money, they break even. And then the 9 cases that they're going to sell is going to be profit. Are you following me?
Yes, sir.
Yes.
So important for them is to sell the 3 cases so that them get back the money, and then the 9 cases them going to have as profit. Now, if out of the 9 cases them sell 7, you think say them give it 2 other cases to go really beat them that much? No. Yes, it's going to cut in on their profit line, but they are not operating at a loss. Are you seeing the point I'm making?
Yes, sir.
So they can go ahead and ban it and just give it away to the customers. And that's why supermarkets do what they do in terms of banning the stuff. It happens with mayonnaise, things with short shelf lives. It happens a lot with. All right? So that's what it is. And that's the end of my session. I know the question is long. Yes, sir.
Oh, I want to tackle 2 things before we end class. All right. So we had a discussion in the WhatsApp group, and we had the date for the midterm for this Saturday. I want to know if that's confirmed by you. And I send
22nd?
Yes, sir. Which is a Saturday. This Saturday.
All right. All right, let me think about it and tell you on Wednesday. I'm going to tell you why. A co-worker mother died, and I am giving a tribute at the funeral in the morning. But sometimes these morning sessions, these funerals can run over.
Yes,
I don't know what time I'm going to be there, and I don't want to say, okay, guys, we're going to meet at this particular time, and then I have you guys waiting. I want to respect your time just as how I really want you to respect my time. So let me speak with the person to find out exactly where I'm going to be on the program and see how best it works out. And then I will come back to you. I promise you on Wednesday and let you know. If not, I would recommend that we put it on the 29th. But let me just check because the distributor I am giving on behalf of the college. So I can't not be there, if it's what I'm saying.
All right. Sir.
Yeah, thanks for bringing that to me, though, Tariq. Appreciate it.
Yes,
I forgot about
and if you can do the question I sent you in the chat for next class. I don't know if
this question? This question?
Yeah,
No,
I sent a question in the chat, so you can. I don't know if we have plans to do more of this.
Oh crap! Guess what happened now, Tariq? Okay. Oh, all right. I thought you say he sent me a question to Mark. All right. Do me a favor, guys. Can you all download the question that Tariq sent in the chat, please? Download the question that Tariq sent in the chat, and that's going to. Woo! Lovely question. Lovely question. All right. Download the question that Tariq sent in the chat for me, please, guys. And this is going to be the question to be done for next class. It's going to be the question to be done for next class. Please, before you leave, download this question. What I'm going to do,
I'll send it in the WhatsApp group, sir.
Okay, great, time. Coming to you, Kenneth. Tarno, what I'm going to do, I'm going to be copying this or the question that I went through just now and send off to you. Go ahead for me, please, Kenneth.
Yes, sir. Just can you remind me of the years for the missing semester, please?
I will do that. I will send it off because I have to go look back at the paper. Okay. So I will send it off. Yeah, man, no problem. All right, guys. In literally 5 minutes, that's if Karno is available. You can look for the solution to the question that I just did. Have a good one.
Okay, sir.
All right, sir. Big up yourself.
Big up yourself.